Assalamualaikum warahmatullahi wabarakatuh. My name is Nurani Isyada binti Zulkifli with matric number 1171467. So in this section, I'm going to introduce to you what is electronic spectra and also the Frank-Condon principle. Electron spectroscopy is an analytical technique to study the electronic structure and its dynamic in atoms and molecules. So in general, an excitation sources such as X-ray, electron, or synchrotron radiation will eject an electron from an initial orbital of an atom. Okay, so we all know electronic spectroscopy depends on the condensed nature of energy state. So without any stimulant, the electron will not excited to a higher level, which means that an electron needs to absorb energy to excited from the ground state to the higher level. Electronic transition occur very fast than the movement of the nuclei. So the transition appear as a vertical lines where there's no change in the internuclear distance, which can be referred as the Frank-Condon principle. Frank-Condon principle is related with the interaction between the electronic and also vibration motion, and likewise the Born-Oppenheimer approximation because the nuclear masses are higher than the electronic masses. This principle states that the nuclear configuration of the molecule experiences no significant change when a molecule undergoing an electronic transition like ionizations, because the nuclei are much more massive than electron and the electronic transition happen faster than nuclei can respond. From the graph, the nuclear axis indicate the effect of the internuclear separations, and the blue and green vertical arrows suggest a vibranic transition. This vibrational transition is sustained during a process called rapid electronic excitations, which result in Coulombic forces. Electronic spectra of all molecules can be shown if the selection rules in respect of vibrational or electronic transitions are irrelevant. So in general, we can say that the probability of the particular transition occurring depends solely on the relative position of two potential energy in the nuclear distance curve. That's all from me. Next, my friend will brief more on electronic spectra. Thank you for listening.